Hello everyone. Hope all are doing well. In today's session, we are going to see a very important topic from physics, that is perpendicular axis theorem. Perpendicular axis theorem comprises nearly 4 to 8 marks in your board examination and has really a major participation in your JEE and NEET examination. So without wasting time, let's see what exactly the theorem suggests. In your board examination, you may get a question like state and prove perpendicular axis theorem, or you may also be provided with a numerical which is based on this theorem. Now, what exactly does this theorem states? The theorem states that in a plane body, where if you want to find out the moment of inertia across any one axis, it can be given as the sum of moment of inertia across any two axes. Now, if you are interested in finding the moment of inertia across z-axis, it can be given as Iz is equals to sum of moment of inertia across x-axis plus sum of moment of inertia across y-axis. And this is about z-axis. That only if you want to find the moment of inertia across y-axis. So moment of inertia across y-axis can be given as Iy is equals to Ix plus Iz. So let's try to derive this mathematically. For a plane body, consider a point P, which is at a distance of r from z-axis, at a distance of y from x-axis, and at a distance of x from y-axis. For this theorem to be proved, you need to use Pythagoras theorem. Pythagoras theorem is applicable for right angle triangles, and it states that hypotenuse square will be equal to base square plus height square. Now, in right angle triangle OMP, by applying Pythagoras theorem, we may have OP square, which is hypotenuse. OP square will be equal to OM square plus MP square. If we substitute the values, OP square will be equal to R square plus X square plus Y square. Now let's multiply both sides of the equation with m, which is nothing but mass of the body P. So we will be having mr square is equals to mx square plus my square. But we know the definition of moment of inertia, which says that moment of inertia is nothing but the product of mass and square of distance between them. So here we can assume, or we can reduce this equation to Iz is equals to Ix plus Iy, where Iz is the moment of inertia across z-axis, Ix and Iy are the moment of inertia across x and y-axis, and this is what we wanted to prove. For stating the theorem, you will be having 1 mark. For the figure, you will be having half mark. For half mark will be given for the denotions, that is for giving the values, and 2 marks are for this proving, for this derivation, and this theorem comprises for 4 marks. If any numericals comes based on the same, they may come for 3 or 4 marks. I hope in today's session you people are clear with perpendicular axis theorem and will be able to solve the numericals based on the same. If you are having any query or any difficulty, please feel free to drop it into the comment section. Thank you for being connected.